Okay, I'm sharing my screen.
Hello, my name is Kim Rademacher, and I will be the instructor.
Okay, so I hope you can see my screen. If not, someone tell me. Okay, so yesterday we have completed or tried to understand EC2, EBS, and S3, three core services of AWS. Okay, today we will enter networking. Okay, so if you remember, I gave you a very simple example of Minfi Office. Okay, what is a VPC and what is a subnet? Okay, so if I take the whole building as an infrastructure, which is true, that is also we call as an infrastructure. Every floor I'm going to consider it as a private cloud. Okay, and inside that every cabin or every desk I will consider it as a every cabin I will consider it as a private subnet. Okay, and the bay area where we all sit I will consider it as a public area, public within the VPC, within the office. Okay, so all my servers or my desk which are there inside the inside in the bay area, every desk person sitting on every desk can talk to every guy. But if you have to enter Vijay's cabin, or if you have to enter Nilesh's cabin or Shankar's cabin, okay, you will. There are, I mean, obviously there is no access restricted. Anyone can go inside. But idea is that is a zone which is separated out. Okay, that simply means that the access is restricted to some level. I mean, some level in the sense maybe the access restriction says that what Vijay is talking to a client or making a deal, that word should not come outside. Okay, that simple wall also says that don't go, just go and enter into Vijay for every town, every different kind of situation. Okay, unless and until there is a big situation, you don't go inside. So there is a certain kind of, I would rather say, mental access restriction. Okay, so and then unless now imagine this, if Vijay has to talk to Shankar and their cabins are next to each other, if you have to talk to Shankar, they just cannot sit on their own chairs and talk to each other without a phone. I mean, forget the phone part, so consider there is no phone. Okay, if he has to talk to Shankar, Vijay has to come out and then go into Shankar's cabin and talk. Okay, now this so this is a proper port channel. But if Vijay wants to talk directly to Shankar, he will have to create a window in the wall between. Okay, I would consider that window to be a tunnel. Okay, some kind of tunnel between both the subnets or both the rooms, so that voice can transfer between each other. So keep this picture in mind. Okay, a picture of what is an infrastructure. The whole building is AWS. Inside the building, one floor for me is a VPC. So my account, my VPC. Okay, inside the VPC, everyone cannot enter our office. Only restricted people can enter our office. Inside the office, every room is a subnet. I would say private subnet, and there is a public subnet where all of us are sitting. Okay, so let's start and see what this gentleman says technically. So people, you guys can hear this right today? Someone say yes.
Security of the AWS cloud is one of
Yes.
Yes, sir. Yes. Make a little louder, sir.
I don't know.
your data.
Does this help?
One of the features I want to talk about
And now, okay.
security groups. At AWS, security groups will act like a built-in firewall for your virtual servers. With these security groups, you now have full control on how accessible your instances are. At the most basic level, it's just another method to filter traffic to your instances. It provides you control on what traffic to allow or deny. To determine who has access to your instances, you would configure a security group. Rules can vary from keeping an instance completely private, totally public, or somewhere in between.
Okay, so private, public, or somewhere in between. Okay, so I just told you how to imagine that. What are the public areas inside our office? The front office is a public area. Anyone can go in. Okay, our bay areas is public area. Private is within the office. So let's
Here's
listen
an
to it.
example of an AWS multi-tier security group. In this architecture, you will notice that multiple different security groups have been created to accommodate this multi-tier web architecture. If we start at the web tier, you'll notice that we have set up a rule to accept web traffic from anywhere on the internet. HTTP is port 80 and HTTPS is port 443. To accept traffic from anywhere on the internet, we'd select the source of 000 0/0.
So 0/0. That simply means allow everyone. Okay, if I give this port, that means anyone from anywhere can connect into this. And when I say 0/0 for people who don't know, it looks like this. This is IP address. Okay, so allow, 0 means allow everyone.
Next, if we move to the app tier, there is a security group that only accepts traffic from the web tier. And similarly, the database tier can only accept traffic from the app tier. Finally, you will notice there has been a rule created to allow administration remotely from a corporate network over SSH port 22. So let's switch over to the console and take a look at creating a security group. Here I am logged into the AWS Management Console, and I'm going to click EC2. In the navigation pane under Network and Security, you'll see Security Groups. Let's click that. Now we see a list of security
One
groups that
thing.
has
Okay,
been
let's look at this again, and I'll again repeat what I said. So suppose this is our building. In that building, VPC is not actually shown here. It's directly showing security groups. So if I put one more layer to this, okay, let's say I'll just take a copy of this, okay, and let's say I put one more layer to this and like this, okay, and I will say this as floor one, floor one or whatever, okay. In that floor one, think of this as this is security group basically. Okay, what you're going to see now is they will also tell you what is subnets and all. Okay, so let me create some more boxes around it. Sorry. Okay, box 1, box 2, box 3, right? And I will name it as Vijay. I will name it as Shankar's cabin. I will name it as our open bay where we all sit. I also sit outside, you see me, right? Okay, so this is our open bay. So what talks to what? It's showing what talks to what. These guys can talk, all these guys can talk to here. Okay, the arrow is not showing different, but you can obviously go and talk to anyone in this company, doesn't matter. But let's say I'm not giving access for this guys to talk to this guy. Go inside this guys. Okay, so ये structure याद रखना. So in technical parlance, I'm sorry, this will be the VPC. This will be the subnet. Okay, and this line that you're seeing inside, this is for me the security group. Who stops you from talking to this guy? From here to here, who stops you there? Maybe some policies. Okay, there's nothing in Minty again, but suppose I create a policy that do not, or Vijay creates a policy saying that by 9 to 1 o'clock, only 4 people can enter my room. Okay, that is a policy. So this is where we, in the security group, we create those restrictions, or rather, we give those white or black listing of servers that can interact, or subnet that can interact to each other. Subnet to subnet. This is subnet, this is subnet that can interact to each other. So keep this photo in mind, and then you listen.
to allow administration remotely from a corporate network over SSH port 22. So let's switch over to the console and take a look at creating a security group. Here I am logged into the AWS Management Console, and I'm going to click EC2. In the navigation pane under Network and Security, you'll see Security Groups. Let's click that. Now we see a list of security groups that belong to the queue. To create a security group, we want to click Create Security Group. A pop-up window will appear. In In this window, you'll notice that you can create a name, a description, and finally some rules. Next, if we go down here to the rules, by default, all inbound traffic is denied and all outbound traffic is allowed. If you want to edit this, you can from here by clicking the inbound and outbound tabs to adjust rules. You can edit by traffic type, protocols, port ranges, and source. Best practice is to figure out what traffic is required for your instance and to specifically only allow that traffic. Let's create a web server security group. For name, I'm going to enter web server SG for security group. For description, I'll say allow web traffic. And just like our previous example, we want to allow HTTP and HTTPS traffic. For type, I select HTTP. For source, I have again the 0000/0, which represents all IP addresses. I want to allow the entire internet. We also have the equivalent for IPv6. I add the HTTP rule, and I have one more rule to add, HTTPS. Again, I want to allow the entire internet on port 443. Now I can go ahead and click create.
So for those who do not understand, if you are in this at all and you don't understand ports, okay, again it is very simple to understand ports. I cannot enter your house without a door, okay. The only other way for me to enter your house is by breaking the walls, right? Forget the windows, don't think about windows, right? That is a different kind of port. I would consider a different kind of port. But if I have to enter your house, I have to get into the door, which is considered, which you can imagine as a port here. Okay. For any information to go inside a server, the first thing you have to do is an incoming message or any connection should connect to the server via a port, and the server should allow it to interact with itself, right? Similarly to if someone knocks your door, you will look from the keyhole and say, who is this guy? Is this guy allowed to come in? If he is allowed to come in, you open the door. Otherwise, you keep the door closed. You just don't open it. So that is what the port does. So this guy is saying any and everyone. So let's say this is a restaurant. Okay, the restaurant's doors are open for any and everyone to come inside. If I restrict this to a private IP, let's say 192.168.0.1 or any other IP, okay, I now am defining that port 80 will open only for few people who come with these particular source address. Okay, remember this thing from the port's perspective.
And now you can see our new web server security group has been created. Let's go over what we discussed today. AWS provides virtual firewalls that can control traffic for one or more instances called security groups. You can control the network accessibility to your instances by creating security group rules. Designing good security groups is necessary for security compliance. Security compliance will be covered in further detail later in this.
Okay. All right. So which of the following statement is true of Amazon VPCs? Each VPC is a private dedicated network connection from your premise to AWS. Or each AWS account can have only one VPC associated with it. You can create many subnets in a VPC though fewer is recommended to limit complexity. A VPC acts as a physical firewall of your cloud infrastructure. Tell me.
Third one you can create
Many subnets. Okay. So let us see. Correct. So in my office, I could have created multiple small cabins. It is restricted, otherwise it will increase a lot of connectivity. No one can move anywhere. No one will be able to talk to anyone. No, we may close this window. Oh, it's over. Very nice. I could have finished this yesterday only. Did we talk about VPCs?
Hello, my name is Kent Rademacher, and I will be the instructor for this module. I'm currently a senior
No, we
technical
didn't.
trainer for AWS and teach architecting on AWS and system operations on AWS. In this module, you will learn about Amazon Virtual Private Cloud, or
And I was
Amazon
wondering what
VPC.
happened. Why are you talking about
I will
security
first
groups?
introduce this service, followed by a feature review of Amazon VPC. We will then walk through an example Amazon VPC configuration utilizing the features previously discussed. Finally, we will summarize and cover next steps for further learning about Amazon VPC. The AWS Cloud offers pay-as-you-go, on-demand compute, as well as managed services, all accessible via the web. These compute resources and services must be accessible via normal IP protocols, implemented with familiar network structures. Customers need to adhere to networking best practices, as well as meet regulatory and organizational requirements. Amazon Virtual Private Cloud, VPC, is the networking AWS service that will meet your networking requirements. Amazon VPC allows you to create a private network within the AWS cloud that uses many of the same concepts and constructs as an on-premise network. But as we shall see later, much of the complexity of setting up a network has been abstracted without sacrificing control, security, and usability. Amazon VPC also gives you complete control of the network configuration. Customers can define normal networking configuration items such as IP address spaces, subnets, and routing tables. This allows you to control what you expose to the internet and what you isolate within the Amazon VPC. You can deploy your Amazon VPC in a way to layer security controls in the network. This includes isolating subnets, defining access control lists, and customizing routing rules. You have complete control to allow and deny both incoming and outgoing traffic. Finally, there are numerous AWS services that deploy into your Amazon VPC that then inherit and take advantage of the security that you have built into your cloud network. Amazon Virtual Private Cloud, VPC, is an AWS foundational service and integrates with numerous AWS services. For instance, Amazon Elastic Cloud Compute, EC2, instances are deployed into your Amazon VPC. Similarly, Amazon Relational Database Service, RDS, database instances deploy into your VPC where the database is protected by the structure of the network, just like your on-premise network. Understanding and implementing Amazon VPC will allow you to fully use other AWS services. Let's take a look at the features of Amazon Virtual Private Cloud, VPC. Amazon VPC builds upon the AWS global infrastructure of regions and availability zones, or AZs, and allows you to easily take advantage of the high availability provided by the AWS cloud. Amazon VPCs live within regions and can span across multiple AZs. Each AWS account can create multiple VPCs that can be used to segregate environments. A VPC defines an IP address space that is then divided by subnets. These subnets are deployed within availability zones, causing the VPC to span AZs. You can create many subnets in a VPC, though fewer is recommended to limit the complexity of the network topology, but this is totally up to you. You can configure route tables for your subnets to control the traffic between subnets and the internet. By default, all subnets within a VPC can communicate.
Okay, so I told you, in this, what I was showing you, basically this is what I, kind of put through. Okay, availability zone, if you remember, is a data center within the cloud, within the region. Okay, this is a region. Within the region, you have, like in Mumbai region, you have 3 availability zones as being depicted here. Okay, in that, I am going to create a VPC. I can create multiple VPCs per account, right? So in my Hive space building, we can create multiple floors. I mean, obviously there is an end to it in the building, but in AWS there is no end to it. We can create a lot of VPCs. Under each VPCs, I can create subnets used to divide the VPC. That exactly is what I mean when I say I create rooms. I used to divide my own floor. Okay. Then route tables control traffic going out of subnets. Okay. Who comes in and who goes out? That traffic is obviously controlled, right? We have this thumb, or whatever we call it, that attendance system. We press our thumb and the gate opens, right? So think of it that where who should enter by clicking on that machine is there in the database. Your thumb impression is in the database. So based on that, if it allows in or allows out. Okay. Internet gateway allows access to the internet from the VPC. Think of this as your in the building construct. What would this? Maybe a window out of which you can go and look out. Something like that. So basically, the servers which are inside a VPC, if in a private VPC, if I will not have internet access. So, oh, I'm sorry. So this is internet gateway. I was talking about the NAT gateway. So NAT gateway is something which allows you internet access on the servers which are inside a private subnet of the VPC. If you don't give a NAT gateway, you'll not be able to open google.com. Okay. Then comes network access control list. It gives you control access to subnets and it's stateless. That means I can control both inbound and outbound traffic. Andar kaun aayega aur bahar kaun jayega. I can control both, right? Using a network access control. All of these are some kind of database. Okay, NACL is some kind of database. Okay, NAT gateway is a kind of database which allows you, saying that this VPC can, allow you the flow of internet. Okay, route table is a database where you go and set in the route tables, set in the IPs that can be accessed or not accessed. Okay, subnet is not a database, but it is a virtual segregation. Okay, in which you get the IPs and all, right? So this is how this whole thing works.
Communicate with each other. Subnets are generally classified as public or private, with public having direct access to the internet and private not having direct access to the internet. For a subnet to be public, we need to attach an internet gateway to the VPC and update the route table of the public subnet to send non-local traffic to the internet gateway. EC2 instances also need a public IP address to route to an internet gateway. Let's design an example Amazon Virtual Private Cloud that we can use to start deploying compute resources and AWS services. We'll create a network that supports high availability and uses multiple subnets. First, since VPCs are region-based, we need to select a region. I've selected the Oregon region. Next, I'll create the VPC. I'll give it a name, Test VPC. And I'll define the IP address space for the VPC. The 10.0.0.0/16 is the classless interdomain routing format and means that I have over 65,000 IP addresses to use in the VPC. Next, I create a subnet named Subnet A1. And I have assigned an IP address space that contains 256 IP addresses. Also, I specify that this subnet will live in availability zone A. Next, I create another subnet called Subnet B1. Assign an IP address space, but this contains 512 IP addresses. I've added an internet gateway called Test IGW. Subnet A1 will become a public subnet where non-local traffic is routed through the internet gateway. B1 will be our private subnet that is isolated from the internet. Let's summarize what we have accomplished and review some next steps we have learned about and how to create VPCs, internet gateways, and subnets. Next steps include learning about other VPC features such as routing tables, VPC endpoints, and peering connections. Also, you can learn about deploying AWS resources into your VPC. More information is available at aws.amazon.com/VPC. I hope you learned a little something, and we'll
In today's video, I'll be
Okay,
giving you a
so
brief introduction.
this is done. This is also done. Okay. So let's see what we can start today. What is the time? 6:30. Okay. So if you have any questions, shoot till the time I open. I hit this. Array. Oh.
Sir, this is Darsharam here. I have one doubt.
Yeah.
Sir, if we create a VPC with 10.0.0.16, with the same VPC range, can we create one more VPC in the same account or in same region?
If the VPC is separate, you can. Okay.
If we can.
A separate VPC altogether.
So we can't create the same VPC like 10.0.0/16.
No. So okay, you're saying the VPC itself. So the VPC range which you are providing cannot be the same in the same zone.
Okay. So if we create like 24 and 16, will it not be differ?
24 and 16. This too, I'll have to get you confirmation from one of our networking guys. Okay, but if 24/16 ideally should not differ, because that 24/16 we are straight away trying to define the number of IPs that are getting allocated to that range. /24 and 16 are saying no. Okay, so that is only defining that, but the range is something which remains on the first 4 dots that you define. Okay, if you say 192.168.0.00/16 or 24, the number of IPs that you can create under 192 differs. Okay, so it remains the same. So you cannot, it will start flashing. Okay, so slash will not make a difference. Okay, but I would like to invite someone who is very good in networking to do this. Anyone who's there who can answer this question? There's so many guys. अरे कोई तो आंसर करो प्रभु, कैसा टीम है तेरा? कोई आंसर नहीं कर रहा है.
Santosh is there, no?
संतोष.
और एक संतोष है ना अपना networking guy. Is that the same guy? I see Santosh there.
Santosh Palli, yeah. Santosh Palli, speak up. Your name has come. Tell कोई नहीं. Tomorrow I'll invite someone, and they will give an answer to this. So the Parashuram, right?
Yes, sir.
ठीक है Parashuram. Tomorrow I'll invite Rakesh or someone. Okay, and we'll start the session with that only, so that you have a right answer, perfect answer to this. ठीक है?
Okay, sir. Thank you.
Okay, now where are we? So yeah, I hate this front end here. I'm never able to find out what is where. This is my WordPress. So what we have completed is 2. This is the one which we need to course. We launched the core services, integrated service. Yeah.
Welcome to Module 3, Integrated Services. This module focuses on some of the integrated services that are part of the AWS Cloud. To make this content easier to consume, the integrated services are discussed in independent videos. By the end of this module, you should be able to talk about key services on the AWS platform and their common use cases. And with that, let's go ahead and get started.
Hi, welcome to our introduction to the application load balancer. In this video, we will introduce the second type of load balancer under the Elastic Load Balancing Service, which is the application load balancer. My name is Seth, and I've been with AWS for over 5 years. I'm currently working as a technical trainer responsible for delivering trainings to customers using Amazon Web Services. Our agenda for this video is to first overview the application load balancer and introduce to you some of the major features included in this service. After that, we will discuss some of the usage scenarios where you could use the application load balancer. Lastly, we will go through a short demonstration of the load balancer itself. Starting off, what is the load balancer? The application load balancer is, as stated earlier, the second type of load balancer introduced as part of the Elastic Load Balancing Service. While it still offers most of the features provided by the classic load balancer, it adds some important features and enhancements that lend it to unique use cases. At a quick look, some of the newly enhanced features include additional supported request protocols, enhanced metrics, and...
So let's quickly understand what is a load balancer for people who are not familiar with this term. Okay, as the name says, it balances the load between multiple systems. So all these 4 servers will be running the same application, a true copy of the application into each other. When the user comes in, this load balancer will send the first user to this, second user to this, third user to this, fourth user to this. If this was not there, then all the load would have come to a single server. Okay, so when there are servers which are applications which have got high traffic, you use a load balancer will distribute the load between multiple different instances below.
Lend it to unique use cases. At a quick look, some of the newly enhanced features include additional supported request protocols, enhanced metrics and access logs, and more target health checks. Some of the additional features for the application load balancer are the ability to enable additional routing mechanisms for your requests using path or host-based routing, native IPv6 support in a VPC, AWS Web Application Firewall integration, and more. There is a vast number of scenarios in which you would use the application load balancer. One is the ability to use containers to host your microservices and route to those applications from a single load balancer. Application Load Balancer allows you to route different requests to the same instance, but differ the path based on the port. If you have different containers listening on various ports, you can set up routing rules to distribute traffic to only the desired backend application. There are some new terms to learn when looking at the Application Load Balancer. While listeners are essentially the same, you can now group the destinations or targets into target groups. There are some new terms. Balancer are the abilities you put in a VPC, ability to use containers to host your microservices, and route. There is a
so let's understand this
in a VPC.
Okay, let's understand this. Okay, path and host-based routing. What is a host? Anything with a www.minfitech.com is a host. Okay, I can have ravi.minfitech, www.minfitech, or anyone.minfitech.com is a host. Path is the /Ravi or minfitech.com/Ravi /Sridhar /Parasuram. Okay. Based on what is there after the trailing slash, I can is a path. Based on that, I can route my my request to maybe server 1 or a server 2 or a load balancer 1 or a load balancer 2 or a 3 or a 4. Okay, each path will define something. So in real world, what happens? The domain/admin will open an admin portal, /user may open a user portal, okay, or /client may use a client portal. Okay, that is how the routing is done. Native IPv6 support, IPs are generally what we know like this. No, sorry. Okay, IPs are something what we know like this: 13.24.25. Okay, 112.10 maybe something like this. Okay, or let us look at this. Okay, we all know this website, right? What is my IP.com? Okay, this is my IP, right? So this is a normal IPv4 IP, but we all know that this is the number which is the number of IPs that I can give, in this permutation is fixed. This is going to end. So we have IPv6. Okay, IPv6 will look something like this, right? This is, you can create n number of combinations when you use this alphanumeric kind of IP address. So very fast the world is moving from the 4-digit I would rather use the word dots IP address to an alphanumeric IP address. Okay, this would start you to understand this difference. And WAF is a web application firewall. Okay, web application firewall is the firewall which safeguards your applications from being hacked. Hackers. So what this simply does is, the creators of WAF are aware of all the hacking techniques. They themselves are hackers, of world-class hackers. Not all the WAF, in sense, the people who would have created the WAF for the first time. Okay. Now what they do is, they know all the ways to that is used by a hacker to hack into a website. They create rules to stop those. So more or less, this guy will stop all the techniques using which you can hack inside an application. Okay, dynamic port, I am not aware of it. I'll have to find out what is dynamic ports. Let me revert to you on that. And then deletion protection and request tracing. Okay, so as the word says, you can protect yourself against the deletion, and you can have a full trace of where the request came up from, okay, and where it has gone, okay, using the application load balancer.
AWS Web Application Firewall integration, and more. There is a vast number of scenarios in which you would use the application load balancer. One is the ability to use containers to host your microservices and route to those applications from a single load balancer. Application Load Balancer allows you to route different requests to the same instance, but differ the path based on the port. If you have different containers listening on various ports, you can set up routing rules to distribute traffic to only the desired backend application. There are some new terms to learn when looking at the Application Load Balancer. While listeners are essentially the same, you can now group the destinations, or targets, into target groups. Because the Application Load Balancer registers targets instead of instances, a target group is how the targets are registered to the load balancer. Here, we can see how the Application Load Balancer routes and organizes backend targets. When configuring the listeners for the load balancer, you create rules in order to direct how the requests received by the load balancer will be routed to the backend targets. To register those targets to the load balancer and configure the health check the load balancer will use for the targets, you create target groups. As we see here, targets can also be members of multiple target groups. As stated earlier, the Application Load Balancer includes both enhanced and added features. The Application Load Balancer has enhanced the supported protocols by adding HTTP2 and WebSocket support. Additionally, monitoring capabilities have been increased by adding metric dimensions, performing more granular health checks, and additional details in the access logs. Some of the added features now supported are path and host-based routing. Path-based routing allows you to create rules to route to target groups based on the URL in the request. Host-based routing enables the ability to have multiple domains supported by the same load balancer and route
So I'll
requests to
skip
target
this. We
groups
already discussed
based
about
on the
this.
test instance AWS Management Console using EC2 container services scheduled containers. So now we'll look at a quick demonstration of the application load balancer. We'll start in the AWS Management Console, and to create a load balancer, we will go to the EC2 console. So once in the EC2 console, you'll see that I already have 2 instances running. I launched these instances so that we would not have to wait for them to start while we were going through this demo. To test and see what I have set up, let's look at the application ELB test instance that I have created. When looking at this instance, we will show that I have 2 containers listening on 2 different ports. So to do that, we will copy the public IP address for the instance, and then in a web browser tab, we will go to the pages that I have set up for the demonstration. The first page is just listening on port 80, and it is test.html. If we go to that site, we'll see that container 1 is working. If we want to see the other port that I have listening, we'll go to port 443 and go to the same page location. And then that will show that we have the second container up and running. So now that we've done that, let's go ahead and create our application load balancer. To do that, in the side navigation pane, we will go to Load Balancers. You will currently see that I have no load balancers created. So to create an application load balancer, first I will click Create Load Balancer, and then I will let the default selection remain, which is Application Load Balancer. After that, I will click Continue, and this is where I start to configure the load balancer. So first, we will name our load balancer. Keep in mind that the name that we put here will go into the DNS endpoint for this load balancer. So I will name this ALB for Application Load Balancer and Test. This will be an internet-facing load balancer, meaning that it will have a publicly referenceable DNS endpoint, and I will leave the address type as default, which is IPv4. For the listeners on the load balancer, the default setting already has it listening for port 80, but so that I can route to the second container from the same load balancer, I will add an additional listener, and that will just be a simple HTTP request to port 443. After that, the load balancer wants us to select the availability zones that we will be running in. With the application load balancer, it requires you to select at least 2 availability zones. So I will select the VPC that I've created for this demonstration, and then select the 2 availability zones that I have created subnets into. After that, we have the option to tag our load balancer. To tag the load balancer, you simply just state the key and value for which you would reference this load balancer. For the one that we're building here, I will set the key to name, and then I will set the value to application load balancer. After that, we can configure the security settings. On this page, we would configure the security settings if we were using an SSL listener. Since we are not, we will go ahead and go to the next page, where we configure the security group. For the load balancer, I am going to deselect the default security group and select the test web server security group that I have set up for this load balancer. After that, we can move forward and configure the routing. This is going to allow you to configure a routing rule for the backend destination for your load balancer. So to do this, because I have not pre-created any target groups, I will go ahead and keep the new target group set, and then I will name the target group. This target group will be named Demo1. The protocol that it's using is HTTP, and the port is going to be to 80. For the health check, it's going to stay an HTTP request, and the health check destination is going to be the simple web page that we have set up, which is test.html. We can also go into advanced health check settings, and this is where we can adjust how we want the health check to be done. In order to make sure that our target is healthy at an earlier time, I'm going to lower the health check interval to every 10 seconds, but I'm going to keep the timeout and the healthy and unhealthy thresholds the same. After that, we start to register our targets. Registering the target is telling the load balancer what instance you want that port to be hit. So I have the instances set up here, and I will go ahead and select the application ELB test instance that has been set up. After I select that instance, I click Add to Register, and you will see that the instance is listed as one of the registered targets. Moving forward, we get to our review page. On the review page, we see everything that we have configured. It's showing the load balancer's name, it's showing the listeners and the routing rules that we have set up, and it is showing the new target group that we have set up with Demo1. After that, we can go ahead and click Create. We see that our load balancer has successfully been created, so we'll close the screen and it will take us to the load balancer dashboard. Because we have two targets that we want to check with this load balancer, in order to register the second target, we must first create a target group. So, to do this, under Target Group, we will select Create Target Group, and this new target group is going to go to the second container that we have set up. So the target group name for this will be Demo2, and it's going to be an HTTP request, but it's going to be forwarding requests to port 443. It's going to be in the same VP.
So just to clarify what is this 443 and all, okay, anything which is SSL, if you see HTTPS, technically it runs on 443. The port number is 443. Anything which is non-HTTP is HTTP, not a secure port, is 80. Okay, so why you don't see these numbers? So typically what happens is when you send a request, let's say google.com, okay, see this is an example of a host-based routing. When you say google.com/Gmail, it opens Gmail, because when I say this Gmail, it would go to a different load balancer. It gets routed to load balancer routes into a different set of instances. But saying google.com/80, oh sorry, :80 opens the website. It has actually redirected to HTTPS automatically. Okay, or I can say 443. Right. Apart from this, if I give anything else, let's say I give 45. Okay, port number 45. And it's looking for it. Okay. Let's see what does it open, or would it open anything at all? So as of now, nothing. Okay. Why you don't see this? Something is opening. So what is there? Okay, anyways, nothing is there. So why you don't see 80 and 443 connected? So every time you hit either 80 or 443 goes appended by the browser by default. So we don't send anything. It is 80, either 80 or 443, depending on whether you're calling HTTP or HTTPS. That is why you don't see here. Apart from this, any other port that you want, you will always have to carry the port. Okay, then it's saying I'm going to connect to google.com on this particular port.
PC, and our health check is going to be the same target but in the separate container. So it's going to be test.html. Under the advanced health check settings, we again have the options to adjust our health check, and again I will lower the interval to every 10 seconds. After that, I can create the target group, and it shows that I have successfully created my second target group. With that second target group, I then have to make sure that I have registered the instance as a target for that target group. Because it's done, I can now go over to my load balancer and verify that I have both ports set up for the listening on the load balancer. But because I set up 443 when I was creating the load balancer, it is currently forwarding it to demo 1. In order to change that, I will click View and Edit Rules. And under the Then, instead of forwarding it to demo 1, I will edit and edit this rule that I've created and forward it to demo 2. Once I've done that, I click Update, and the rule to route traffic hitting port 443 on the load balancer is now forwarding to the target group, demo 2. I can now go back and view the load balancer. Now that we have created our second target group and registered it to the load balancer, we can test to verify that our traffic is being sent to each container. To do that, we will again copy the DNS name, and then in a new tab, for the first container, we will paste the DNS name, and we will go to the target that we have set up for the demonstration, which is test.html. And we can see that container 1 is available. To test the second container, we have the load balancer listening on port 443, so we will set it to go to port 443, which should forward traffic to 443 on the instance where container 2 is listening. If we hit enter, we can see that container 2 is now up and running. If we would like to adjust the listening for the load balancer, we can always go to the Listeners tab and add or edit the listeners that we have running. In review, this demonstration covered launching an application load balancers, configuring the routing rules, registering the targets to the load balancer, and then verifying the operation of the application load balancer's routing. I hope you learned a little something and will continue to explore other videos. I'm Seth with AWS Training and Certification. Thanks for watching.
Okay,
Hi, I'm Andy
so
Cummings
with
with
this
AWS
we will
Training and
end
Cert-
today's session. Okay, what you have seen today is the load balancer. Just think about it that if there was no load balancer, none of the internet portals which have real sizable traffic coming in would have actually been able to run. That is how important this component is. Okay, and then let's look at tomorrow auto scaling 53 RDS. Wonderful. So I think this will take 2 sessions because below are the topics that I love. I was talking networking, which I don't like. Okay, so let's see, right? So we'll team up tomorrow at the same time again, okay, and then continue with this. Thanks a lot. Parsham, I'll get your answers tomorrow. I'll get Rakesh Shaw on this. Okay, any kind of network questions you want, you can list down and you can talk to him tomorrow. Okay, so thank you, and others also. If there's anything networks, please raise that question tomorrow to Rakesh. He will answer it. All right. So thank you. Thanks for coming today also, and tomorrow we'll check it out.